This video goes through a few handy things for when you're writing maths proofs, so some notation. Okay, so there's a couple of things that are just short phrases, so you might already know. We can use 3 little dots to be therefore, and the converse of that is essentially like because. Okay, so sometimes it's just handy to write. We also use something instead of saying for all. So an upside down A stands for all. So for example, we could write something like n squared is greater than or equal to 0 for all n. Okay, I'm going to clarify that further and say for all n that are real numbers. Okay, so this R symbol represents the real numbers, and this E is an element of the real numbers. Okay, so we'll pop that one on there too. So it's an element of the set. Okay, so this will come up quite a lot in proofs in Additional Pure. All right, you don't have to do that. You can write actual words, but if I'm being lazy or if you want to be going to university, you'll use this quite a lot. Okay, and then already mentioned are the symbols that are for imply and is implied by, which is used an awful lot in proofs. So if we write if A then B, we can write that instead as A implies B. So if A is true, then B is true. A being true implies B is true, and we can write that in maths as A implies B. Okay, so for example, if we had that if x equals 3, that implies that x squared equals 9. Okay, and then going back to front, we can have A only if B. All right, so that means A is implied by B. Okay, so we would write that as A and then a backwards arrow B. So if B is true, then A is true. So it's just writing it back to front. So for example, we could have that 2x is 6 is implied by x equaling 3. But in fact, that would be true going either way. So a better thing to write would be something like this. So A is true if and only if B is true. Or A is implies and is implied by. Just write that again. So implies and is implied by B being true. Okay, so that would mean that if one's true, the other one has to be true, and vice versa. Okay, so we would write A and then we do a double-headed arrow B. Okay, and another way of writing that, just because you need extras, is instead of writing if and only if, you write if with 2 F's. Okay, so these all mean the same thing. They're all used in maths. And so you can use any version you like. You can write it out in words, or you can pick a symbol, or you can write if with 2 F's. So really, this 2x equals 6 implies that x equals 3, but also x equals 3 implies that 2x equals 6. So it goes both ways. So for this one here, really a better example would be essentially back to front version of the squared, because you can't go backwards from the squared, because if you square root the 9, you could get positive or negative 3. So if I put x squared is equal to 9, that's implied by x is equal to 3. You'll do this again in normal maths at A level. Okay? Right, so the implies things are really handy. They're really good when you've got an equation and another equation, because we don't just put equals between them. So for example, if you're manipulating some algebra, so let's do, I don't know, 2 brackets x plus 3. We've got some equation equals 10. So then I could say that this implies that x plus 3 is equal to 5, and this implies that x is equal to 2. And in fact, we would be able to reverse any of those processes. So we could put a double-headed imply sign. So if 2 brackets x plus 3 is 10, then that means that x plus 3 is 5. If x plus 3 is 5, then that also means that 2 times that is 10, and so on. Okay, I hope that helps.